So what I would, when you look at 5, you look at 6, 8, and like really want to kind of chunk that problem up. You have it's the plain old number. There's an X piece, there's a Y piece, there's a Z piece, and you just kind of look at each piece individually and say, what can I do to simplify this? All these problems we're simplifying, right? Which our overarching simplification idea is PEMDAS. So what order do I do things in? But we're just simplifying this. So can I make 10 any simpler? Dividing by 5 doesn't make it simpler. That makes it different, right? Like if I take like 5 tenths and I say, well, I can make 5 tenths simpler. I can divide both of those things by 5 and get down to 1/2. I'm making that number simpler, but I'm not changing its value. It's still, they're both equal, still the same. Yeah. So we can't do anything to make 10 simpler. It's just 10. Now what about x to the -3? So yeah, so x to the -3 wants to move to the bottom, right? So there we can say, well, no negative exponents, but instead I put that x to the 3rd on the bottom because it wants to be positive. All right. So okay, what about y to the 0? Okay. So anything to the 0 power is 1. So I could have times 1, but is 10 times 1? It's just 10, right? So essentially the y to the 0 is just goes away, right? Because there is the 10 there holding the place, we don't need the 1. So yeah, essentially the 1 can just go away. And then what about z squared? Can we do anything with that? No. Yeah, it's kind of like the 10. It's already as simple as I can make it. So it just kind of stays put. So kind of seeing what happened there, right? The negative exponent dropped to the bottom. The 0 exponent just kind of went away because it was 1. We didn't need it. And then the 10 and the z squared, which didn't need to be manipulated, they just stayed put, right? So there it is. There's our simplest answer, or there's our simplest form of that problem, that expression. So when you guys are doing these problems, there's kind of like a checklist of 4 things you need to make sure that you've addressed. They may not all be there, but if there's any fractions in the problem, like number 6, if there's any fractions like this, they need to be reduced. That was like kind of the first thing you look for. If there's any negative exponents, they need to be addressed, like we did there on 5. If there's any 0 exponents, they need to be addressed, like we did there on 5. And if there's any of the same letter, like there on 6, we see 2 A's, we also see 2 B's, so those letters need to be combined. On number 1, you see multiple X's. So if there's any of the same letter, they need to be combined in the appropriate way. You can't have multiple of the same letter in the expression when you're done. So reduce any fractions, deal with any 0 exponents, deal with any negative exponents, and then combine any of the same base. So like there's 2 A's, there's 2 B's, there's 2 X's. Get those combined. And if you've done all those things, you should be done.
So for 6, would it be, I've already asked, would it be 5 a to the 4th over 7 b to the 5th?
Yes.
Okay. And whenever you're like subtracting.
Hold on. So adding. Wait. Actually, I think you did make a mistake. So what'd you do with the 10 and 35?
10 minutes and 5.
What are you reducing by?
2 should be 2 over 7.
All right, so the 10 over 35 should turn into 2 over 7, dividing 5 out of both those. And then what happens with the 8 to the 7th over the 8 to the 3rd?
So dividing is subtract 8 to the 7th by 8 to the 3rd.
Okay. Yeah, subtract 8 to the 7th minus 3, which of course gives you 8 to the 4th. And then what about the b's? So what's here?
It should be a
Yeah,
one.
so b to the 1st minus 6 since we're dividing. So you got b to the -5. So then what'd you do with your 8 to the 4th?
It would go on top.
Why does it go on top?
It would go on top, but then you get down. That's negative.
Okay, there you go. Right. So the positive exponent tells you to put that on the top. The negative exponent tells you to put the b on the bottom, and then go ahead and make it positive. So just let you the sign just let you know where to put it on the fraction. Positive one should end up on the top. Negative one should end up on the bottom, then become positive. And there'd be our reduced, simplified form of that one.
Also another question. So whenever there's an exponent in parentheses, exponent on the outside of parentheses, like number 1 or 2, do you multiply right there?
Yep.
So you like the x squared, you multiply that by 4.
Yep. So power to a power, right? Like you said, Aiden's, that's multiplication. And then power times a power.
I said it would either be x to 11 or
So when it says divide you,
subtract.
so when it says multiply you.
Yeah, that'd be x to 11.
So power to a power, that's the multiplication. 2 times 4, right? Power times a power, that's addition. And those are the two most often confused because they are very similar looking. But negative exponents are a very common misconception. Zero exponents, very common misconception. Okay. Anything else on these 6 you guys want to go before we move to the next section?
Is 2 125x to the 6 y to the 9?
How'd you do that, Mason?
So I basically just distributed the power.
Okay, so you took that 3 and put it on the 5.
Yeah.
Okay.
And I just did that all in one, which made 125.
Okay, so then I gave you a 125.
And then you, since it's inside the parentheses, we're going to multiply the powers. And it's going to be 6, x to the 6, and then y to the 9.
Okay, cool.
9.
Yeah, it's 9, not a 6, whatever, it's 6. Good.
One more question. Why is there just a random, to the right of...
It's not random. It's not random. June, is that good for you on 2?
You didn't have a ring.
It's not random, is what I was saying. But I understand why it looks that way. June, are you good on 2? So on 3 there, I was just trying to point out the difference. A very common misconception about what 0 does and when. Anything to 0 power is?
1.
1. Okay. So when we see the 12 and the y both having the 0 on them on that first part, right, they would both, think about what you just said, Mason, that essentially distribute. You get 12 to 0, times y to 0, which would just be 1 times 1, which of course is just 1. Okay. But when you're looking at the second one, right, they look so similar to start with, but the second one, realizing where the 0 is, it's only on the y. So this is 12 times 1, so it's 12. Okay, so just when we say that everything to the 0 power is 1, that 12 doesn't have a 0 on it. So it doesn't turn into a 1. Right? So just that visual, I wanted you guys to see that again. It's a very often confused problem. So they look so similar, but they're different the way they get applied. So. I guess since we're here, and all the other ones, 8 to the negative 2, what's that mean? 1 over 8 squared.
1 over 8 squared.
Which is 1 over 64. Okay. Negative exponents want to be fractions. Negative exponents want to move. Okay. Negative exponents do not give you negative answers. Okay. That's the most common misconception with negative exponents is they give you negative answers. They do not do that. All right. Okay, so reducing radicals, first semester we did square roots. Second semester we took that bigger, 4th roots, 5th roots, 3rd roots. Okay. What'd you say, Brian? You said 7? So what's x to the 10th mean? You're not Brian. 10x is doing what? 10x is doing what? You guys are a bunch of not Brians over here. So we got 10x's that are multiplying. And then Brian, what's that 4 telling us to do? We want. Say again? Truth. So it's telling you how big of a group you want to find. All right, so we want to find groups of 4. Okay. So we have 2 groups of 4, and then we have these 2 that don't get grouped. All right. So when you have a group, where do you go?
Or outside?
Outside, yeah. If you got friends, you got to go outside, right? So one x gets to go outside, another x gets to go outside. We have to make sure that we write that radical down, the whole radical, not just the square, not just the radical itself, but it's a fourth root. So don't lose the index. That's a really common mistake. People lose the index. You also don't want that index to get a little, what I would say would be leaky, where it drifts off to the left and ends up on the x. It needs to be right up there next to the radical. So make sure that number's there. Make sure it's tight in that spot. And then we got those two x's that didn't get grouped. Now all that was multiplication, right? And it's still all multiplication. So it's just all that. So what's on the outside, Brian? Okay, so we have x squared times the fourth root of what? Okay. So the fourth root of x to the 10th is equal to x squared times the fourth root of x squared. So there's our simplified or our reduced version of that that radical there. So. Mm-hmm. Yeah, the 5 is only on the x, the 80 is, an 80. What we talked about, first semester was that idea of using the sock method to break that number down. So find the smallest number that goes in it, put it on the left, 2 times 40. 40 is 2 times 20. 20 is 2 times 10, and 10 is 2 times 5. So you work it down to its prime factors. And then what are we looking for from there, Brian? Groups of 4 again. So we got 4 2's. Also have 4 x's. And then pay attention to what's not grouped, right? But I see that 2 come out. That x also going to come out. So just 2x. It's fourth root. Again, keep that 4 kind of tight up against the radical. Don't let it drift over towards that x. And then we had a 5 and an x that were left over, so 5x on the inside. So the problem would have been the fourth root of 80x to the 5th, right? Just saying that. It's been a while since you guys have said those or heard that. Fourth root of 80x to the 5th. The simplified version of it is 2x times the fourth root of 5x. Again, there's a little multiplication there. We just don't write it. And when we talked about it in the moment, I just kept telling you guys, give yourself a little space there so it's not all mushed on each other. But the multiplication is there. And 8 and 9 are just, essentially what we did there with the 80. So just do that same thing with 8 and 9, but just make sure you're paying attention to what groups you're looking for, what size of groups you're looking for. So, 11, 12, 13, 14. So those are really just back and forth from one thing to the next. We talked about negative exponents. We talked about zero exponents. What do fractional exponents do? What do rational exponents do? And that was just a different way of writing a root. Right? So these two problems here just kind of go back and forth from each other. So it's, how do I take this and rewrite it like that? How do I take this and rewrite it like that? So it's just going back and forth. So 6 to the 2/3 is going to be some sort of root of 6. I just got to figure out which root it is. It is the cube root of 6 squared, 8, right? So I always like to look at the denominator first, because that's the index, and then I look at the numerator next, because that's my power. So the cube root of 6 squared, or I showed you guys another way to write that, was the cube root of 6 squared. Right. The first way is less writing. The second way, I told you when we were doing that in the moment, that if we went to do something with that, we'd probably prefer it to be the second way. You guys aren't going to be taking these any further, so if you just want to write it the short way, you can. But they mean the same thing. You can see that on 13 is written more like the second way, even though it's the same thing. So 13 is just undoing what we just did. So the first thing I see is that x. So I'm going to be writing x to some power. Like when I'm done, it should x to some power. It's going to be some fractional power. So x to some fractional power. And so again, I like to look at in this case, the index first, because that's going to be my denominator. And then the power is the numerator. It'd be x to the 3/5. Just make sure you're not writing it like this. Think of somebody very particular who here. Okay. It's especially important if it's a number, like if you had 7 to the 3/5. 7 and 3/5 is very different. Like that's a mixed number versus a number with a power on it. So you gotta be really careful about your handwriting here. That needs to look like an exponent, not look like a fraction that's being added onto it. So that's what that means. It means 7 plus 3/5 when we write that. Or it just means 7 to the 3/5 power. Very different. So those were kind of the quick things. The stuff on the back is much more intense, like as far as a work level. But we got to talk about some stuff real quick before we go into that, because we're going to need some skills again from first semester that we were using back in January and February that we remembered at the moment. It's been a while since we talked about those. So. Of course, square rooting. The square root of 25 is just 5. When we go to square root negatives, that's an imaginary number. Okay? Square root of negative 25 is not negative 5, it's 5i. Square roots of negatives are imaginary. So what about the square root of negative 144? 12i? Okay. And then we go look at the square root of negative 18, and we know what to deal with the negative is going to be an I, but then square root of 18, we would need to sock that out. So as I look at the square root of 18, I say, well, how do I break down 18? That's 2 times 9, which is 3 times 3. It's a square root, so we're going for groups of 2. Right? There's a little hidden 2 right there. So I've got a group of 2 3s, then I've got this lonely 2. Almost. Nope. So the 3 gets to come out because it's got a buddy. The I comes out. 3i. Radical 2. So when you said 3 square roots of 2i, it's not clear there is where your I is. Okay. You always want to put stuff in front of a radical because the I needs to be out of the radical. Versus, we could mean the right thing if I say it like this, but we got to really watch out. Again, handwriting can be a big issue there because if that radical gets a little bit long, it's like, is that I in the radical or isn't it? And we really don't want that ever to be a question, so you always push it to the front instead of at the back. So normally we put numbers in front of letters. The only case you don't do that is when there's a radical involved. That you would put anything in front of a radical so it doesn't accidentally appear like it's in the radical. So mathematically that's okay, but it's not good handwriting wise. It's not the convention that's been accepted there. So. Again, what is I? I is defined as the square root of negative 1. And when we want to square root a negative 1, that's where the I comes from. So if we say I times I, of course, anything times itself is that thing squared. So that'd just be I squared. So if we take negative 1 and we square it, sorry, we take the square root of negative 1 and square it, what do square roots and squares do to each other? Cancel. So we're left with just negative 1. So I squared is equal to negative 1. Again, when we did this, back in December or January, whenever we were talking about that, those were two things right there. I said you should just know these. For what we're going to go and do with this stuff, you should just this just basically needs to be a fact. 2 plus 2 is 4. You just need to know what I squared is. You just need to know what the square root of negative 1 is, so you can do the rest of the stuff faster. You're not sitting there trying to figure it out each time. So we can take that and we can take something like 5i times negative 3i. And it's kind of like we talked about on 5 and 6. Just kind of chunk these problems. I'm going to look at the numbers. All right, what's 5 times negative 3? Well, it's negative 15. And then I'm going to look at the i's, right? I times I is I squared. Well, we know what I squared is, though. All right, we have a simpler way of saying I squared. I squared is equal to negative 1. Right? So using that, right? So then our final answer would be positive 15. So we're going to come back and do one of those there at the bottom, but I just want to point out where we're going to be using this. Right? When do you need this skill here? When you're looking at a problem like 15 or 16, you might end up having to solve and get an imaginary answer. And so in that solving process, square rooting a negative or stuff like that could pop up. When you're looking at a problem like 17, you see the i's there already. And so then how do I work with i's? And that's what those last two things we were just looking at will help us do. So how do we work with i's? So we're going to come back here in a second and work on a couple of these, but just kind of pointing out like where you'll need them, those skills here that we're talking about right here. Okay. Last little kind of skill that was a big thing first semester, a huge thing first semester, factoring. We haven't talked about it much here recently at all. I think maybe a couple of weeks ago we talked about factoring like a little bit, but it was earlier in the semester we were doing it still some, but it's been a while since we really talked about factoring, especially solving by factoring. A trinomial, a quadratic trinomial. It's our AC method problems.
We skip that.
Yeah, I don't want to do every problem because we don't have time. So AC method. So A times C. Our AC is negative 42. We need negative 42 to add to be B, so 11. So those factors of 42, they're going to give us an 11. So of course 1 and 42, 2 and 21, 3 and 14. Ooh, I can get 11 out of 3 and 14. I need a negative 42, but a positive 11. Yeah, right. Right, negative 3, positive 14. So we have our 2x squared. And then minus 3x plus 14x. So make sure you put those x's back on. The whole point of the AC method is really how do you break this number up in the middle? Right? It's the whole point of it is to take that number right there and break it in a very special way. Okay? It was that 3 and that 14 that we needed. Okay? And once it's broken, then we do the factoring by grouping. So we say, okay, cut that in half. I say, well, what's common between the first two terms? Okay, they both have an x. So it'd be x times 2x and x times negative 3. And what's common between the second two terms? 14 and 21 both have 7 in them, but it's positive 7, so I need to make sure I put a plus sign there. It's a really commonly forgot thing is that that plus sign does need to be there. And 7 times 2x and 7 times negative 3. You stop and say, well, am I doing this right? And it's telling you, okay, this is going well. These are the same. Those aren't the same, and then you made a mistake somewhere. It's going to try to talk to you. Don't force it. Then once you've got that, you're almost done factoring. The 2x minus 3's go together. And the x plus 7 goes together. So don't lose those zeros. They need to be following you along because this is an equation you're trying to solve. So we're done factoring. Now we need to solve this. So the idea is that the answer is supposed to be 0. You're saying what x value would make this 0?
Negative 7.
Yeah, negative 7, right? So a lot of times we can just look at it and say, oh, that's, we can see it. Okay, so that's x equals negative 7. You're supposed to be asking yourself the same question here, what x value would make this 0, but sometimes it's harder to see with a little bit more complex problem. So if you need to, 2x minus 3 equals 0, and then you just solve that two-step equation. That's all it is, right? Add the 3 over, divide by 2. So there's our 2 answers. And we knew there was supposed to be 2 answers. So we talked about quite a bit was that square tells us that there should be 2 answers. Okay. So again, that's something we did so many times, but it's just been a while. Okay, solving by factoring. But Algebra 2, this is by far one of the number one skill you should walk out of Algebra 2 with is how to factor. You should know that. Spent so much time talking about that. Okay? I know it's been a while, but ask any math teacher what Algebra 2 main skill is factoring. Okay. Anything real quick on the front before you go and look at some of the kind of bigger ones on the back? This is kind of a blast of stuff.
Will you be uploading like a video?
We'll look at 16. So we're being asked to find the zeros of the polynomial given the zeros. Back when we were doing this, zeros is a word for solutions, which is a word for x-intercepts, which is a word for roots. So a zero is the same thing as a solution. So find the solution. Okay. I'm giving you one of the answers. This says there are 4 answers. So that means your job is to find 3. Okay? So there's 4 answers. I'm giving you one of them. Your job is to find the other 3. Okay? This was a pretty long process. This is where we use synthetic division. We learned about synthetic division first semester. Then we took that skill and said, okay, I can take that answer that I know and I can divide it out. I can make the problem smaller by dividing out what I know. So we're going to shrink the problem first off by taking out the answer we know. And then from there, we should be able to factor it. If we tried to factor this, we wouldn't have any success. Okay? We're looking for zeros. It's not generally done, but what that means is that this whole left side is equal to 0 now. We're trying to find a 0. So that means we're trying to find where the y is 0. Okay? That'll come back later, but it's not a big deal for right now. Our synthetic division, that's where we do that little half box. Then we grab the coefficients. Remember the other thing too was to look for gaps. I don't think I'll have to worry about finding gaps on these because they're very hard to write a problem like this that has a gap in it. So there's a 1 in front of that x to the 4th. There's a 2 in front of that x cubed. There's a 22 in front of the x squared. There's a 50 in front of the x, and then there's the negative 75. So make sure your signs are right as you bring those down. If any of those were minus signs. That negative 3 is just going to come over here. We did talk about certain ones where there had to be a sign switch as you brought that over. You guys won't have to worry about that because that was when we said, divide this out. Like if I gave you a factor to divide out, then you had to worry about switching the sign. You guys won't be doing that. So don't worry about the sign switch stuff. Just bring that number right over. Okay. That first number drops all the way down. And then we do all that multiplying and adding. And this is something you guys did a whole bunch of back then. You guys were really good at it. Okay. Synthetic division is really easy. It's just kind of getting back on that bike. All right. Multiply, add, multiply, add, multiply, add. So negative 3 times 1 is negative 3. That goes up to the right. Then you add down. 2 plus negative 3 is negative 1. So I have negative 3 times negative 1, which would be positive 3. And add down. 25. Negative 3 times 25, negative 75. Add down, which is negative 25. And negative 3 times negative 25 is positive 75. You add that down, and you get 0. And that, remember I gave you guys a 0. This last number has to be 0. If it's not 0, that's kind of its way of telling you that you messed something up. Okay. So, we talked about that idea of little built-in checks. This has to be 0. Okay. We're finding the zeros with a given 0. I gave you one of the zeros. Remember, a 0 is another way of saying a solution. So I gave you one of the zeros, so it better give you 0 when you divide it out. It's kind of the way to think about it. So there's, check 1, right? We got the 0, okay, we divided it correctly. Remember, the first step of the division was to take out the x's. The last step of the division is to put the x's back in. But our problem needs to be smaller. We're shrinking the problem. We had a 4th power here. We're taking one of the x's out. That means this has to be a 3rd power. It has to shrink down. If it doesn't shrink, then what was the point of doing this? Okay, so now it's x to the 3rd. So that means the next one would be x squared. Next one's x. Next one after that is just a plain old number, what we called our constant, right? So we get 1x cubed minus x squared plus 25x minus 25 equals 0. So that's where that 0 that I was talking about earlier comes into play. We're saying what's the zeros, what's the solution? So this side was 0, so now that 0 is over here. It's not that 0. No, it's not that one. It's this 0. Okay? And there's our equation to solve. But we should be able to solve that one now with our big tool, which is going to be factoring. How do we factor when there's 4 terms? Split in half, right? Factor by grouping. Okay. So what's in common in those first 2 terms? Nope. Positive x squared. Look at that first term, Aiden. The first one's positive, so bring on a positive. Okay. So x squared times what? X minus 1. X minus 1. And what's common in the second 2? So x squared times what is x cubed? Is x, right? X squared times what is negative x squared? Negative 1. Second 2 have 25 in common. It's positive 25. So put that plus sign there. And 25 times what? X, and minus 1. There's that second built-in check. Are those parentheses the same? Yes, they are. Sweet. So we've got the 0 like we needed. Our parentheses are the same like we need. So things are going well. X minus 1 goes together. X squared plus 25 goes together. So we're done factoring. So now we're at that solving step. Just like we were right here. All right, we say what value of x makes this 0. Sometimes we can just see it, and sometimes we got to do a little bit of work. Okay? So what value of x is going to give us 0? So one time we can see it, another time we've got a little bit of work to do. Okay? X would be 1. That would give us 0. Then I'd say x squared plus 25 equals 0, and then we solve that simple equation. So kick the 25 over, so we got x squared equals negative 25. How do we unsquare something? Square root, yep, good. And then when we square root, we do have to square root the other side, but this is one of the most commonly forgotten things. When we square root. All right, Kyla, plus minus. There's 2 answers here. Right? There's 2 answers to this equation. One of them is positive, the other one's negative. Then what is the square root of negative 25? 5i. So there's 2 answers. And then look how many answers we have. 1, 2, 3. So there's our 3 answers we said we were going to get at the beginning of the problem. So that's why it's important at the beginning to say, what am I actually trying to do? Okay, I'm going to go get 3 answers. So when you're done, you're like, oh, yeah, I did get 3 answers. Sweet. Because if you knew you were supposed to get 3, but you only had 2 written down, you'd be like, where's my 3rd answer? Like, you at least you'd have some knowledge that you'd be like, I'm not done. There's something else I'm missing here. All right, and that'd be the point where you say, that'd be the point where you're, raising your hand saying, what am I missing here? Like, here's what I got. I know it's not right. Like, again, you guys can say something like that. I'm super happy. Like, you're saying, here's what I've done. I know something's not quite right about it, but I can't figure it out. I'm more than happy to help you guys. You don't have to write them all separate like this. If you want to write the plus minus, you certainly can. I'm just doing that so you guys can see, yes, there are indeed 3 answers. And the fourth one, which is the one I gave you guys. So, there's the 4 solutions to that problem. Okay. So there's, that was a pretty big problem. This is like definitely one of these problems we look at and we say, if you guys can do these, we're really happy because it's showing you can do all sorts of different skills and combine them and problem solve through this. That I can factor, I can divide, I can solve a square root problem. There's a lot of skills in there. So these are really, as a math teacher, like a good problem to assess you guys on. It shows me a lot of things, or could show me a lot of things. Yeah. So I'd like you guys to try, 15 on your own if you can. And then I just want to maybe start one of these here. I don't know if we'll finish it, but and then if you guys need to ask questions about the last 2 tomorrow or whatever, you can. This is essentially the backwards of what we just did. I'm giving you the answers. I want you to give me the problem. Right? I want you guys to write a function. Write a function. Write a problem that has these answers is essentially what this says. You don't really need to worry about the rational coefficients part. You don't really need to worry about the leading coefficient of one part. It'll take care of itself if you do the problem correctly. It'll just happen. You don't need to worry about making it happen. But I'm giving you the answers. Okay? I'm giving you this part. How do we work backwards up to the function which started this? Well, where it starts is, where did this 1 come from? 1 came from x minus 1. So that the trick here is to make sure you switch that sign as you write it back. We need to write this. And well, if my answer is 1, then my factor must have been x minus 1. So if my answer is negative 2, then my factor must have been x plus 2. If my answer's 4i, then my factor must have been x minus 4i. If my answer is negative 4i, then my factor must have been x plus 4i. So make sure those signs get switched.
You look at the 4 i's.
Yeah, you can. If you guys did this enough, like we'd start saying you guys could skip that step, but we want to see it because definitely not everybody's there. And if you just have the answer all of a sudden, it's like, how did that happen? So yeah, you're right on, Aiden, but yeah, we want to see how you got there. Okay, so now we need to multiply those back together, right? Part of our work on the last one was to divide it apart. Well, now we need to multiply these back together. And again, in the moment when we talked about this, I talked to you guys about why you should do these 2 first. You get to decide how you multiply this back together, but you would be so much better off doing those 2 first than any other order. And it's just foiling. It's just double distribution. X times x. X times 4i, which is be positive 4i x. Negative 4i times x, which is be negative 4i times x. And then negative 4i times positive 4i, which would be negative 16i squared. So those 2 terms in the middle are going to cancel. And then we talked about what I squared was. That's just negative 16 times negative 1. So that's really just a positive 16. So we end up with x squared plus 16. So that's why we wanted to do those 2 first, because now the i's are gone. And if we had taken the x plus 2 and mixed it with the I first, the i's would still be there, just in a messier way now. And so it would be, it's not impossible. It's just so much harder if you do it that way. So start here instead of the beginning. And then bring that x plus 2 down. And again, the rest of that's just a little bit more FOIL, and then you're done. So. And when I said use function notation, what I was saying by that is just when you're done with your answer, put f of x on it or g of x or whatever to be done with it. But the rest is just a little bit of FOIL. Okay, so you guys could finish that on your own. right? But look at the other problems that we didn't do yet. Okay, you need to come back tomorrow with questions. It's not that many to do. It's like 5 problems or something like that. Let's see if how they're feeling about it.